All right, hi guys, welcome back to your final NTI lesson. This is the last online video that you have to watch for NTI. The school year is almost over. You guys will take a quick quiz over this, but then otherwise that's it. So let's go ahead and jump in. This is example 5 in exponential growth. So we're gonna take it back to our original exponential growth model. All right, so I'm just gonna read the question and then we're gonna go from there. It says, Tia knew that the number of emails she sent was growing exponentially. She generated a record of the number of emails she sent each year since 2009. What is an exponential model that describes the data? So it says write it in the form y equals a times b to the x, which is great. We know that one. Y equals the emails in hundreds, and x is equal to the number of years since 2009. Use the data to find the values for constants a and b. So the data that it refers to is this information right here. Without this picture, we would not be able to do the problem. This picture tells us that in 2015, she received 1,000 emails. In 2016, she received 1,400 emails. So we need to fill in the equation a times b to the x and fill in a and b. So we know that a is the initial value. So for us, that's going to be the number of emails, not at the beginning of time, because she didn't start tracking it until 2009. That's our initial value, is how many emails she had starting in 2009. And then B is going to be our growth factor. We know it's growth and not decay because it's increasing. It went from 1,000 emails to 1,400 emails. And that is going to be the growth rate of emails, okay? So we actually know one of these constants just from this bit of information right here. Because these years are consecutive, meaning they're 1 year apart and our model is in years, we actually are looking at our growth rate right now. So I want to know, what would I multiply 1,000 by times what would give me 1,400? That's what I want to know, right? That's our growth value. If I had 1,000 emails times what gives me 1,400 the next year. So I would just divide both sides by 1,000 and x equals 1.4, or b equals 1.4, okay? You could say that b is just the 1,400 over the 100, which is 1.4. So I'm filling it in, y equals, I still don't know a, but I know that b is 1.4 to the x. So now what I want to do is I want to figure out a. I want to figure out the initial value of my emails in 2009. But what happens is when I'm looking at an equation that's got multiple variables, right now I got 1 variable, 2 variables, 3 variables. I cannot solve for one of them until it's the only variable in the equation, meaning I have to plug in something for x and something from y. So we're remembering from the beginning of the year. We are remembering from any time we've looked at a graph. We know that x is an input and y is an output. So we know that x is time, and time is in years since 2009, and y equals the number of emails, okay? So if x is time, years since 2009, and y is the number of emails, we can turn these little tidbits of information into an x and a y. So 2015 is 6 years since 2009, and she gets 1,000 emails. 2016 is 7 years since 2009, and she gets 1,400 emails. So I just came up with 2 different x-y pairs. So now I have something to plug in for x and something to plug in for y. That way a is my only variable. So I'm just going to use the second one because I like 7 better. So I'm going to plug in 1,400 for y a times 1.4 to the x is 7. And so now if I want to solve and I want to get a by itself, I'm going to divide both sides by 1.4 to the 7th, 1.4 to the 7th to just make it go away. And then we can do that on our calculator really quickly. You can either do 1400 divided by 1.4 to the 7th like that, or you can do alpha y equal so it looks more like what you're looking at on your paper. Whoops. And then 1.4 to the 7th. Either way, we're going to round that. We're going to say 133. So we're going to say that a, our initial value, is about 133. So my equation would be y equals 133 times 1.4 to the x. The question says to write it in hundreds of emails. So what that means is we would actually move this decimal over 2 places, and that's how the book writes it, which is totally fine. So you could have that, or you could have y equals 1.33 times 1.4, but that one you have to say in hundreds instead of just using the actual units. I prefer you just do this one because that is the initial value. She got about 133 emails in 2009. But yeah, that's your final answer. So the outputs, just divide the bigger one over the smaller one, and that's how you get B. And then the trickiest part is coming up with these x and y's, but then plug them into your equation, and yeah, you'll solve for A. If you have any questions, remind FaceTime. Remind Google Meet. We can do a Google Meet if you need to. Google Classroom comments or emails. But yeah, get excited. This is our last lesson. I'm going to really try to wrap all this up for you guys and get you out of here, in the best shape possible to be ready for your math class next year. But yeah, I love you guys so much. This has been a weird and interesting ride. I never thought we'd end the year like this, but I love you guys so much. You guys have been an awesome class for me when we were in school and online. You guys have just been kicking butt, and yeah, I love you guys for it. Can't wait to see you guys the next time I can see you. I love you so much. Thank you for all the work that you guys have done on your own. You guys are really awesome, and I'm incredibly, incredibly proud of you guys.